Hey guys, welcome to 3.2. Yesterday we solved systems by graphing, and it was the intersection point, right? Today we're going to solve systems by substitution. Yesterday when we were graphing, it works great as long as your points work out. If your points don't work out well on your graph, that intersection point is not on a nice, easy intersection of the graph, it's really hard. You have no idea what the answer is. So we need to turn to other methods, and one method is substitution. So our essential question: how do you solve systems of equations by substitution? Some vocab to get us going here. Substitution is the action of replacing something with another thing, right? If you have a substitute teacher, you're replacing the regular teacher with a fill-in teacher, right? So the substitution method, basically, we're going to solve, we have, two equations, right? We're going to solve one of the equations for one of the variables. Okay, so we're just going to get a variable by itself. And then we're going to substitute that into the other equation. Alright, so here we need to solve by substitution. So this one is already solved for y, right? Y is all by itself. So we're going to take this 5x right here, and we're going to substitute it for y. Since y and 5x are the same thing, we can switch it out. Okay, we can substitute it. So we're going to plug in 5x instead of y, and we get 12. Okay, now x plus 5x would be 6x equals 12, and so x equals 2. Okay, we got 1/2 of our coordinate point. Now, in order to find the other half, we're going to plug 2 back in for whichever one we feel is easiest. This one's going to be easier in this situation because it's already solved for y, which is what we need to find. So we're going to go y equals 5x, and we know that x is 2, so 5 times 2, so y equals 10. Okay, and so our answer is 2, 10. Now, it says check your answer. Go ahead and check it. You plug it back in, plug these numbers back in for both equations. We're not going to spend the time just because I have limited time on the video. So now solving by substitution. Now for here, it's not solved already for one variable like it was here. So we need to usually just pick the easier one to do. This one is by far easier to get something by itself. And let's get y by itself, so we're going to just subtract x from both sides. And so this equation is just y equals 3 minus x. Okay. Now every time we see y in this equation, we can plug in 3 minus x. So we just keep going. So 5x minus 3y. Oh, I saw a y. So I'm going to plug in 3 minus x. That all equals -1. Okay, from here we need to distribute 5x minus 9 plus 3x equals -1. Okay, I'm going to combine my like terms, so we get 8x minus 9 equals -1. Add 9, from here is just solving an equation, so we get 8x equals 8, and so x equals 1. And that's half of our answer. Don't stop here, because now we need to go back up to the equation that we choose. This one looks easier to me, and so we're just going to plug in -1 for x. So, and actually, we already solved this one for y, didn't we? And so we might as well actually just use this equation because it's already solved for y. So y equals 3 minus 1, which is our x value. Okay, and so y equals 2. Our final product, x is 1, y is 2. There we go. Okay, using substitution again. Now this time I'm going to just switch it up a little bit. All right, I'm gonna solve for x this time around. You could solve for y. Like, actually, it'd probably be easier to solve for y in this problem because y is positive. But I want to mix it up, so we're going to solve for x. So we'll subtract. Actually, we might as well add x over to the other side. You'll see where I'm headed here in just a second. Then we're going to subtract 2. And so we get x equals 3y minus 2. Okay. Now we're taking this And we're going to plug it in every time we see x into this equation here. Okay, so we'll just keep going. Y plus 2x. Oh, I saw an x, so therefore I'm going to plug in 3y minus 2, and then equals 3. Okay, I distribute, and so we get y plus 6y minus 4 equals 3. And y and 6y is 7y minus 4 equals 3. I add 4. We get 7y equals 7. And so y equals 1. Again, that's half my answer. Now, since I'm trying to find x, I might as well use this formula right here. You could plug it back up into these formulas, and that's fine. It's just more work, and this is a little bit faster. So 3, my y is 1, minus 2. That'd be 3 minus 2, so x equals 1 as well. So my final coordinate point is 1, 1. Alright, so you're in charge of ordering labels for a small business, and a company makes custom labels. They charge a yearly fee plus the cost per label. So you paid $375 last year, and you ended up purchasing 300 labels. This year, you ordered 1,000 labels, and you ended up paying $725. So what's the yearly fee and the cost per label, assuming that they didn't go up in price? Okay, so last year's equation, we had the fee plus the cost per label times the amount of labels you had, and that equaled the total amount you paid, right? Now, if we plug in our stuff here, the fee we don't know yet. We also don't know the rate, but we know that we bought, 300 labels? And we ended up paying $375. Okay, so this is our equation for right now. And then this year, if we use the same exact formula, we still don't know the fee, we still don't know the rate, but we're buying 1,000 labels, and we're spending $725. Okay, so I'm going to solve one of these for f, and then we'll plug it in. So this is really 300r, right? So I'm going to just do this one. So we get f equals 375 minus 300r. I solved it for the first one up here. Okay, so now every time I see an f, I'm going to plug in this equation. And so here we go, f plus, oh, sorry, hold on, back up. I already saw an f and I went right past it. Instead of f, we need to plug in this, right? So 375 minus 300r. Okay, plus 1000r. And that equals 725. Okay, now we combine our like terms. So we end up with 375 minus 300 plus 1000 would be plus 700 r. Okay, we subtract 375. We get 700 r, and this would end up being 400. Right? Yeah, 400. Okay, so then our r, the rate is 400 over 700 when we divide, and that ends up being 4 over 7 is our rate. Okay, so 4/7 of $1 probably, which would be 57 cents per label. Okay, we'll say 0.57, 57 cents per label. Now we need to also find out what the fee is, right? And so we're going to plug in 50. Let's plug in 4/7. It's a little bit more accurate. We don't have the rounding error. And so f equals 375 minus 300 times 4/7. Okay, this is calculator work. 375 minus 300 times 4/7, and our phi is $203.57. Okay, so our fee is that much, and our rate 57 cents per label. All right, we got two more here. Now let's solve for substitution, and just like we have been, right? This is already solved, so that works out really nicely. So we're just going to plug that in for y, and we'll end up with 3x minus 4 minus 3x equals 1. All right, well, 3x minus 3x that cancels itself out, right? And so we're left with negative 4 equals 1, but hold on, that doesn't make any sense because those don't equal each other. So what do we have? Well, we have no solution. All right, and last one here. You know what, looking at these, it's going to be really easy to get this y by itself because it's just kind of sitting there alone. All I need to do is move the 2x over. So for this one, we're going to do y equals negative 2x plus 4. Okay, and every time we see a y, we're going to put in that equation. And so we have 3x plus 5y. Oh, I saw a y, so I'm going to plug in negative 2x plus 4. And that all equals 13. Okay, first step, distribute. And so I end up with 3x minus 10x plus 20. That all equals 13. We combine like terms. Here we get negative 7x plus 20 equals 13. When we subtract 20, we get negative 7x equals negative 7, and so x equals 1. Solve part of it. Now I need to find my y. I might as well use this one because it's already solved for y. So y equals negative 2x, but I know x is 1, plus 4. Oops, 4. So we have negative 2 plus 4, which is 2. Okay, and so our final coordinate point 1, 2. All right, that's it for section 2.